What if I told you that the next time you step onto an airplane, the concept of a crash was as outdated as a flip phone? It sounds like science fiction, right? But right now, we are on the very edge of a revolution in aviation that could make air travel virtually infallible. This isn't about making flying safer. We've been doing that for decades. This is about engineering a future with zero failures. Imagine a world where every single flight is guaranteed to land safely, no matter what happens mid-air. This vision is closer than you think, and it's powered by some of the most advanced technology humanity has ever created. So, how do we get there? It's not just one magic bullet. We're talking about a symphony of groundbreaking technologies all working together. Think of AI so smart it can predict a problem before it even exists. Quantum computers running simulations so complex they can model every single atom of an aircraft. And blockchain technology creating unhackable, unfalsifiable records of every single maintenance check. And we can't forget about smart materials that can literally heal themselves. It's a total reimagining of what an airplane is and what it can do, where every component is intelligent, interconnected, and ridiculously resilient. The mission is crystal clear and incredibly ambitious: to completely eliminate all preventable crashes and, in the 1 in a billion chance something does go wrong, to maximize passenger survival to a near 100% certainty. We're going to build a system so robust that human error, mechanical failure, and even unpredictable weather become problems of the past. So buckle up, because today we're going to build the safest airplane in the world, piece by piece, and show you exactly how we can make the dream of a zero-failure future a reality. Okay, so every flight starts on the ground, and that's where our first line of defense comes in. Before any plane even thinks about pushing back from the gate, it will undergo the most intense health checkup imaginable, all run by a powerful AI. Picture this: sensors embedded in every single part of the aircraft, from the engines to the landing gear to the tiny bolts in the wing, are constantly streaming terabytes of data. This AI system doesn't just look at the current state, it cross-references this real-time information with the plane's entire history, which is stored on an unchangeable blockchain log. So, every flight, every repair, every replacement part is part of the calculation. This isn't just a simple checklist. The AI compares the live data to a perfect digital twin of the aircraft, a flawless virtual model that represents the plane in its ideal factory condition. It runs millions of simulations in seconds, looking for microscopic stress fractures, temperature anomalies, or pressure variations that are completely invisible to the human eye. If there's even a 0.001% deviation from perfection or a slight inconsistency with its maintenance history, the system flags it. The flight is grounded automatically, with a precise report telling the engineers exactly what's wrong and how to fix it. This eliminates the chance of an undetected fault ever leaving the ground. Now, a plane is only as good as its last repair, and human error in maintenance is a huge factor we need to eliminate. So, we're bringing our AI supervisor into the hangar. Every single maintenance event, from a simple tire change to a full engine overhaul, is monitored by an AI-driven surveillance system. We're talking about high-resolution computer vision cameras and advanced sensors that track every single action a mechanic takes. The AI has access to the official manufacturer's manual and the plane's specific digital twin, so it knows exactly how a procedure is supposed to be done, down to the specific torque that should be applied to a bolt. If a mechanic misses a step, uses the wrong tool, or even looks at the wrong part for too long, the system provides a real-time alert on their smart glasses or tablet, gently guiding them back on track. Think of it like a super intelligent assistant that prevents mistakes before they happen. Furthermore, every new part installed is scanned, its serial number is verified against a global database, and the entire maintenance action is automatically recorded on that same tamper-proof blockchain log we talked about. This creates a perfect, unbroken chain of accountability and ensures that counterfeit parts or shoddy workmanship never compromise an aircraft's integrity. Once we're in the air, we need to account for the human element in the cockpit. While pilots are incredibly skilled, they are still human. That's why our future aircraft has an advanced AI co-pilot that's always on, always alert, and always ready to help. This isn't about replacing pilots, it's about augmenting them. The AI continuously monitors thousands of data points from the aircraft and the external environment, from weather patterns hundreds of miles away to the subtle changes in the engine's hum. It can suggest more efficient flight paths, predict turbulence with pinpoint accuracy, and manage routine tasks to reduce pilot workload. But here's the most critical part. The system also monitors the pilots themselves. Using non-invasive biometric sensors in the seats and controls, and even eye-tracking cameras, the AI can detect signs of fatigue, stress, or a medical emergency like a heart attack. If a pilot becomes incapacitated or makes a critical error, the AI can instantly take control of the aircraft, stabilize it, and communicate with air traffic control to execute a safe landing at the nearest suitable airport. This provides an ultimate safety net against the most unpredictable factor in aviation: human fallibility. So, what happens if something actually breaks mid-flight? In today's planes, a single engine failure is manageable, but a total loss of thrust is catastrophic. In our future plane, that's not a concern because we've built in layers upon layers of redundancy. Alongside the traditional jet engines, the aircraft is equipped with multiple, independent, electrically powered propulsion systems. These aren't just small backups. They're powerful enough to keep the plane flying safely to an airport. If the main engines fail, the electric systems kick in automatically and seamlessly. This philosophy of redundancy extends to every critical system. The flight controls aren't just double redundant, they're triple redundant, with mechanical, hydraulic, and fly-by-wire electronic systems, all capable of controlling the plane independently. An AI-powered adaptive system constantly monitors the aircraft's performance. If it detects a failure, like a damaged wing flap, it doesn't just send a warning, it instantly recalculates the plane's aerodynamics and adjusts the remaining control surfaces to compensate, keeping the aircraft stable and controllable. It's like having a brilliant flight engineer on board who can redesign the plane in real time to handle any damage. Okay, now for the scenario that everyone fears the most. A catastrophic, unrecoverable failure mid-air, like a complete structural collapse. Even with all our other systems, we need a last resort. So, what if the plane itself was the problem, but the passengers could just leave? This is the concept of the detachable passenger cabin. The entire section of the fuselage where the passengers and crew are seated is designed as a single reinforced module that can separate from the wings, engines, and tail section in an extreme emergency. Once the system detects an unavoidable catastrophe, a series of explosive bolts would fire, cleanly severing the cabin from the rest of the airframe. At the same time, a set of massive parachutes stored in the roof of the cabin would deploy, dramatically slowing its descent. Retro rockets at the base of the module would fire just before impact to cushion the landing, whether it's on land or water. This transforms an unsurvivable event into a rough but controlled landing. It's a radical idea, but it shifts the focus from trying to save the entire aircraft to guaranteeing the survival of everyone inside. Even in a less catastrophic but still serious incident, like extreme turbulence or a hard landing, passenger injuries are a major concern. That's why every single seat in our future aircraft is a cocoon of safety. We're installing smart airbag systems that go far beyond what you have in your car. These aren't just front impact airbags. We're talking about a network of airbags that deploy from the seat back in front, the armrests, and even from the seatbelt itself, creating a protective bubble around each passenger. These systems are controlled by an array of intelligent sensors, including accelerometers and gyroscopes embedded throughout the cabin. The central AI processes this data in milliseconds, and if it predicts an imminent impact or a violent maneuver, it triggers the airbags fractions of a second before the event. The system is smart enough to adjust the deployment speed and pressure based on the severity of the expected impact and the size and weight of the passenger, which it knows from sensors in the seat. This custom-tailored protection dramatically reduces the risk of injuries from whiplash, impact with cabin surfaces, or collisions between passengers. In any emergency on the ground, time is honestly the enemy. Evacuating a full plane in 90 seconds is the standard, but, well, we can do better. Let's start with the windows. In our aircraft, every window is also a potential emergency exit. The smart glass in the windows can be made opaque for privacy, but in an emergency, it instantly becomes transparent. If the AI detects a fire or blockage at the main exits, it can identify the safest side of the plane for evacuation and automatically trigger the ejection of specific window panels. These aren't just pop-out plugs. The entire window frame is ejected outwards by a small controlled charge, creating a clear and immediate path out. Simultaneously, LED light strips embedded in the floor and ceiling will illuminate the fastest and safest path to these newly created exits, dynamically changing if conditions shift. The smart glass can also display instructions or arrows, guiding passengers directly. This system bypasses the chaos and bottlenecks of traditional exits, dramatically speeding up evacuation and getting everyone to safety faster than ever before. Fire on board an aircraft is, without a doubt, one of the most terrifying and dangerous situations possible. Our approach is twofold: prevent fuel from ever igniting and extinguish any other fire instantly. Firstly, the fuel tanks are completely redesigned. Instead of traditional aluminum, they are made from crash-proof, self-sealing polymer composites. If the tank is punctured, the material instantly reacts to seal the hole, preventing fuel leaks. The fuel itself is stored in a foam-filled bladder that suppresses vapor, making it incredibly difficult to ignite even in a severe crash. For any other type of fire, like one from a lithium-ion battery in the cabin, an AI-driven suppression system takes over. A dense network of thermal and chemical sensors can detect a fire the instant it starts, long before humans would see smoke. The AI pinpoints the exact location and deploys a targeted response, not a whole cabin flood of Helen, but a localized burst of fire-suppressing agent. For the most extreme cases, we're even developing nanobots that can be released into the cabin. These microscopic robots would actively seek out and neutralize fire at a molecular level, stopping it cold without harming the passengers. You know, a lot of aviation risk isn't actually on the plane itself, but in the crowded sky all around it. To manage this, we're creating a global unified air traffic control system powered by artificial intelligence and a next-generation satellite network. This system doesn't just track planes, it creates a dynamic four-dimensional model of the entire global airspace: latitude, longitude, altitude, and time. It knows where every single aircraft is, where it's going, and where it's predicted to be at any moment in the future, with, well, pinpoint accuracy. This AI doesn't just react to problems, it proactively prevents them. It can predict potential conflicts or congested airspace hours in advance and automatically suggest optimized, deconflicted routes to every plane in the system. It also integrates real-time data from weather satellites, geological sensors, and even social media to predict hazards like volcanic ash clouds, extreme weather, or security threats. With every aircraft constantly streaming its position and health data via satellite, incidents like the disappearance of MH370 become honestly impossible. Every plane is always visible, always connected, and always on the safest possible path. Technology is of course great, but we can't forget the people, both crew and passengers. We need to prepare them better and keep them safer. For crew, training moves into hyper-realistic virtual reality. Pilots and cabin crew can practice responding to any conceivable emergency, from engine fires to cabin depressurization, in a completely safe but incredibly immersive environment. The AI can introduce unexpected twists to the simulation, ensuring they are prepared for anything. In the air, the same AI that monitors pilots also discreetly monitors the cabin crew for signs of stress or incapacitation, ensuring the whole team is always at its best. For passengers, safety becomes more personal and intuitive. Biometric sensors in the seats can monitor vital signs, allowing the crew to be alerted to a passenger in medical distress even if they're asleep. The pre-flight safety briefing becomes an interactive VR experience you can view on your phone or in-flight screen. And for the most extreme scenarios, we're even exploring the concept of individual survival pods. In the event of a cabin breach at high altitude, a transparent shell could deploy around each seat, providing a pressurized, breathable atmosphere until the plane can descend to a safe altitude. It's about creating layers of safety that protect every single person on board. In this hyper-connected system, data integrity is, well, everything. We need to ensure that all this critical information, from flight data to maintenance logs, is completely secure and can never be tampered with or lost. That's why the traditional black box is getting a major upgrade. Instead of just recording data to be recovered after a crash, our new system continuously streams all flight data in real time to multiple secure ground servers via an encrypted satellite link. This means that no matter what happens to the aircraft, the data is already safe. And to guarantee its authenticity, every piece of data, every sensor reading, every pilot command, every maintenance entry is logged on a distributed, encrypted blockchain. This is the same technology that secures cryptocurrencies, and it creates a digital record that is mathematically impossible to alter or fake without being detected. This tamper-proof log provides a perfect, indisputable history of the aircraft's entire life. This not only makes accident investigation instantaneous and flawless, but also acts as the ultimate deterrent against cutting corners or covering up mistakes. It's the foundation of trust for our entire zero-failure system. So when you put all of these pieces together, the AI pre-flight checks, the redundant systems, the detachable cabins, the global traffic network, the impact is honestly staggering. Conservative models show that implementing this integrated safety ecosystem could lead to an 80% reduction in crash rates, and potentially even higher. We're talking about saving thousands of lives and preventing hundreds of incidents every single decade. It transforms aviation from an industry that is incredibly safe into one that is practically infallible. This is the single greatest leap in aviation safety since the invention of the jet engine itself. What we've explored today is more than just a collection of cool gadgets. It represents a fundamental shift in philosophy. For over a century, aviation has been built on a principle of risk management, making things safer, but accepting that a tiny amount of risk will always exist. We are now moving into an era of fail-safe design, where the system is so intelligent, redundant, and resilient that failure is no longer a statistical probability to be managed, but a flaw to be engineered out of existence entirely. It's about building a system where the safe completion of a flight is the only possible outcome. This future isn't a distant dream. The technologies are here, and the path forward is clear. It requires bold investment, international collaboration, and a relentless commitment to innovation. But the goal is within our reach, a world where no one ever has to fear flying again. It's a profound promise to every person who steps onto a plane, a promise of a journey as certain as the sunrise. The sky belongs to those who dare to reimagine its safety.